This lesson is for 4.3 on solutions to equations. So today our objective is to be able to determine if a point is a solution to a given linear equation. So we've been working with linear equations, we've been graphing them so far. Now we're going to see if we have a solution to a given linear equation. So let's first talk about what it means to be a solution. So we've been solving linear equations, that's what we did in chapter 3. This first example here asks us to solve for x. So if we had to solve this, we all know what to do. We just subtract 4 on both sides and we end up with x equals 2. This is the solution to that equation. It means that that's the only value that I can plug back in for x in order to get a true statement. So we ask you guys to check, right, when we were first learning how to solve equations. So if I did 2 plus 4, I definitely get 6, so that checks off. If it was not a solution, I would get a false statement, but here I get a true statement when I try to plug in the solution. Now in question 2, it asks if x equals 2 is a solution to this equation right here. So if they're asking if this specific value is a solution, all you have to do is plug it back in order to check to see if it actually is a solution. Just kind of like how we did over here to check to see if our answer was right. So in this particular example, if I plug in 2, I want to use order of operations. I'm going to do 3, and then 2 minus 4 gives me negative 2. But in this example, I end up with a false statement because on the left side, 3 times negative 2 is negative 6, which is not equal to 6. So this is false, which means that 2, x equals 2, is not a solution here to that equation. So in other words, a solution here, let's fill in the blank, it produces a true statement when it's plugged back into an equation. Now the whole point of this lesson is to see what happens when we have two variables like the equations that we've been graphing in this chapter. So what happens if we have an equation that looks like this, 2x minus y equals 11? Well, in this case, you're going to get a coordinate pair, an x and a y, in order to be able to plug x in for x and the y in for the y. Okay, so instead of having just a number, you'll actually get an ordered pair. So you have to check both numbers and plug it into the original equation. So it's really similar to what we just did. We just have to do this twice. We just plug in, I'm going to do 3 for the x here, so 2 times 3, and then minus, when I plug in y, this is negative 5, right? So I actually end up with a double negative. It's inside here. If I plug that in, I end up with that double negative, so I'm going to change that to positive. So I have 2 times 3 plus 5 equals 11. So if I check this, 2 times 3 is 6. 6 plus 5 does equal 11. So this one checks off, so this is a solution. So 3 negative 5 is a solution to 2x minus y equals 11. So to fill in that blank here, a solution, again, it produces a true statement when x and y are substituted into the equation. So again, we had to plug in both x and y into that equation. Alright, now in the last part of this lesson, we're going to try to answer this question here. What does the solution look like with respect to a graph? So for right now, we're actually going to ignore this graph here. We're going to try to answer A and B first, and then we're going to see what similarities we notice with the graph of the equation. So this first question says, is the ordered pair negative 4, negative 8 a solution to 3x plus 4y equals 12? So notice it is the same as this equation here with the graph below it. But we're going to answer this just like we did in the problem right above. We're just going to go ahead and plug in this x for the x right here, and we'll plug in the y value, negative 8, in for the y. So we just plug it in to see if we get a true statement or not. So we would have 3 times negative 4, and then plus 4 times negative 8. We want to see if that is equal to 12. So if we check this, 3 times negative 4 is negative 12, plus 4 times negative 8, that's negative 32. And I'm seeing right away that this is a negative value here, so negative 44 definitely does not equal 12, right? That's not true, so this is a false statement. Now, if we come to the side over here, after I write false statement here, if I come to the side, if I look at the point negative 4, negative 8, negative 4, negative 8 is all the way down here. Notice how far away it is from that line, right? This does not lie on the line of this equation, 3x plus 4y equals 12. So this was not a solution to the equation, right? if we try to list some points that are solutions to 3x plus 4y equals 12, all we have to do are pick points that are on the line, like negative 4, 6. Negative 4, 6, if I try to check that in the original problem, 3 times negative 4 plus 4 times 6, if I use my calculator here, negative 12 plus 24 definitely equals 12. So this shows that it is a solution. So rather than having to check all the time, if I have a graph, it's really nice. I can just look at the points that are on the line. Those are all solutions to the equation. So I had 1 point, negative 4, 6, right? There's 1. Second point, 0, 3. This is a solution to the equation as well. And I've got the point 4, 0 also. And then lastly, this point down here, if I wanted to list a fourth point, I could. So let's just go ahead and do that one. 8, negative 3 is also a solution to the equation. So the big idea of this lesson is if you're checking to see if something is a solution to an equation, all you have to do is plug it in, right? When you have an x and a y in your equation, you have to make sure you plug in both x and y. If you have a graph, though, it's really pretty easy. You just take a look and see whatever points lie on the graph of the line, then those are definitely solutions. If it's not on the line, like down here, negative 4, negative 8, that was this original point that we tried to plug in here, we notice we get a false statement. It's because it does not lie on the graph of the line. Okay, so that's the big idea for today. We're going to use that tomorrow in class, so good job. I will see you guys tomorrow.